Okay, let's look at this question here. You're supposed to, if you look at the waveform here, you're going to get a voltage versus time graph, right? And the first question there is to state the form of modulation, and is if you can notice there, the amplitude is being varied, and hence it is amplitude modulation. So it has to be AM there. Amplitude modulation should be there. Okay. If you check the next part of the question, they ask you the frequency of the transmission. Now you can't transmit. If you want to transmit the wave, you don't transmit the audio wave. As you can see, that's the whole point of using a carrier wave. So the frequency of transmission would be the frequency of the carrier wave. So frequency is transmission is frequency of the carrier wave, right? So frequency of the carrier wave. Sorry, my pen is not working, so I have to use the mouse. So frequency of the carrier wave, which can be found as 1 over time period of the carrier wave. So you can actually find 1 over time period of the carrier wave. And if you notice here, you can, if you count number of waves, that's 1, 2, 3, 4 and 5 carrier waves in a time of 100 microseconds. So if you want to find a time period of one carrier wave, 5 waves was 100 microseconds, so one carrier wave would be 20 microseconds. So it would be 1 over 20 microseconds, so 20 times 10 to the power negative 6. You calculate that, you should get an answer there. So that's 100 over 5 or 50,000 hertz, I believe 50,000 hertz. You do the calculation with the calculator. Now the next part of the question is frequency of the modulating waveform. Modulating waveform. Now what is getting modulated? The carrier wave is getting modulated. What is modulating it, or what determines how much to modulate the carrier wave? It's your audio signal. So the question here is frequency of the modulating waveform means what is modulating the carrier wave, what determines how much to modulate the carrier wave? It's your audio frequency. So your modulating waveform is your audio frequency. I know they could have just asked you what is the frequency of the audio wave, but they try to make you understand what is the meaning of modulating waveform there. So modulating waveform is frequency of the audio wave, which can be actually figured out by looking at two similar peaks. Now if you find this peak here, and if you notice that the peak ends, this would be a similar peak there, and I think that those are the two similar peaks. So the time period of the audio signal is 200 microseconds. So if you want to find it, it would be 1 over 200 microseconds. 200 microseconds times 10 to the power negative 6. So it's just 1/10 of this value, which would be 5000 hertz, right? Okay, I've been using the word 50 kilohertz and 5 kilohertz because few of your questions I've seen are similar to 5000 and 50,000 hertz. Now the next part is to draw a graph to show the variation of frequency and versus signal voltage. Now this can be power, it can be amplitude, it can be anything, right? Power can be power or amplitude, and you definitely would have three straight lines, I believe. So you should have three straight lines there, right? And with that as 50 kilohertz, but please put 50,000 there, and that would be 55,000, right? You do it in your paper, right? 55,000, and that would be 45,000. 45,000 there. Now these are the sideband frequencies, and that is the carrier frequency. So you should know that the sideband frequency should be lower in voltage than the carrier frequency, and they have the same height on both sides, so same voltage on both sides. The distance from here to here should be equal, but because they say draw a graph, so careful when you draw. So just make sure that the distances are same. It's 3 marks there, so they're going to be very critical about marking your paper. So just draw it, the middle one bigger. How much length? It's okay as long as these two are same and this is bigger and these distances are same. Okay. So if you continue, you know what is meant by amplitude modulation. I've given you 4 points for that. You could write the first 4 points. I suggest you write all 4 points if you can fit it in the sentences. If not, the first 2 points are actually good enough already. So the next part is to determine the wavelength at which the radio station is broadcasting. So if you want to find the wavelength of the broadcastings, you need to find the wavelength of the carrier wave. So for that I need the frequency of the carrier wave. Frequency of the carrier wave is going to be 50,000 hertz or 50 kilohertz, 50,000, 50k. And if you want to find lambda, lambda equals to c over f. So if you substitute the value of speed of light, it's 3 times 10 to the power 8, 10 to the power 8 divided by 50 times 10 to the power 3, you're going to get 3 over 50, so 30 over 50, so 300 over 50, so 6,000 meters. I'll just check the calculation. I'm not sure whether the value is 6,000, but just check. It should be large, quite large, because radio waves are quite large in wavelength. Now the bandwidth of the radio signal would be the distance from the lowest sideband frequency to the highest, or twice the audio frequency. So if you look at the bandwidth, it's 53.5 minus 46.5, so let's say it's 54 minus 47, so it would be 7 kilohertz. That would be the bandwidth of your radio signal. Now the maximum frequency of the demodulated signal, when you say demodulated signal, that should be your audio signal. Now bandwidth is twice the bandwidth equals to twice of the maximum audio frequency, and hence audio frequency would be half of the 7, which would be 3.5 there. Next question, you see define what is meant by frequency modulation. All 4 points there that I've shown you before. Now this is a FM question here. The variation with time of the signal voltage is shown in 14.1. Now 14.1, it's here. This is the signal. I actually turned the page here. So the question is, determine the frequency of the unmodulated carrier wave. It has to be unmodulated carrier wave because the modulated carrier wave has many frequencies. So for that, what you have to you have to find two similar peaks here. So if I'm not mistaken, those two are similar, as you can see, or you start counting. That's 1, 2, 3, 4, and then those three are quite big. So I have 1, 2, 3, 4, and those two are quite big. Those three are quite big. So if not, you just find the thicker one. The fatter ones are easy to recognize. Okay, so it's good to be fat. Okay, 4 to 12 kilohertz. 4 to 12 microseconds is the distance, or the time distance between for one complete waveform. So in this case, 12 minus 4 is 8 microseconds would be the time period of the audio signal. So to find the time period of the audio signal, you're supposed to figure out two similar peaks, and the height is the same, but you find those two peaks which would be similar, and the distance between those two similar peaks would be the time period of the audio signal. Now if you want to find the time period of the carrier wave, the problem is the carrier wave has got so many frequencies. So what you do is start counting. So that's one waveform, right? That's the next waveform, that's the next waveform, and that's 2, that's 3, that's 4, that's 5, 6, 7, 8, 9, and I believe that's 10 waveforms in between 4 and 12 microseconds. So 10 waveforms would be 8 microseconds. So one waveform would be, which means the time period of the carrier wave, the average time period of the carrier wave is going to be 8 microseconds over 10, which would be 0.8 microseconds. So once you have the time period of the carrier wave, you can actually find the frequency, because the question is frequency of the carrier wave would be 1 over time period of the carrier wave, which is 1 over 0.8 microseconds. 1 over 0.8 microseconds, that would be, okay, that would be 10 over 10 to the power 6 there. So 10 to the power 6 would be 10 to the power 10 to the power 6, and that would be 10 over 0.8, which is 125, if I'm not mistaken. Yeah, not 12.5. Is it? Wait. So 10 over 0.8 is 12.5. So 10 to the power 5 there, 12.5. So it would be 12.5 times 10 to the power 5. 10 to the power 4 actually. So 125 kilohertz. Yeah, it would be 125 kilohertz. So you do that with a calculator. You find 1 over you find 1 over 0.8 microseconds. You should get the answer already, right? I believe it's 125 microsecond kilohertz, 125 kilohertz. Next part is the information signal, and you have the audio audio time period. So you just have to find 1 over 8 microseconds. You should get 125 hertz. Now a second system of modulation is AM. One advantage and one disadvantage of FM and AM. The advantage of FM is good quality of audio, and the disadvantage would be the circuit is complex, and it's and you have less number of broadcasting stations, or you can also say that it's more expensive because you need repeater amplifiers, right? One last question here again, what is FM? It depends on the marks. If you have time, if time permits, you write all the points there. If not, I suggest you write the first 2 points that I've shown you before, right? Now here this is slightly different. A carrier wave has this amplitude and this frequency. The frequency of the carrier wave changes by 25 kilohertz per volt. So frequency of carrier wave is changing, which means this is a question based on FM. Now it changes 25 kilohertz per volt. The carrier wave is used to carrier wave is for a frequency of 3. So this is your audio frequency. This is your audio frequency. This is your carrier frequency, and the amplitude is 2 volts. The question here is for the frequency of the state the amplitude of the modulated carrier wave. The amplitude is a frequency modulated carrier wave. The amplitude of the carrier wave should be the same. So answer is still 12. It doesn't. The amplitude of the carrier wave is kept constant in FM. Next question is maximum frequency. Now frequency of the carrier wave is 600. Now you're going to change this frequency. Now how much to change depends on the displacement, right? So the displacement or the maximum displacement of the audio signal is 2 volts. Now that is 25 kilohertz per volt. So if my audio wave has got 2 volts there, then the carrier wave should change by 50 kilohertz, which means my maximum frequency would be, carrier wave should change by 50. Carrier wave is 600. It should change by 50 means that it should increase by 50 or it should decrease by 50. So those are your answers: increase or decrease by 50. 650 and 550, there are your answers there. Now the number of times per second the frequency of the carrier wave changes, it depends on how many times to change, depends on the frequency of the audio signal. So you see 3 kilohertz, which means 3000. So you have to change 3000 times in a second the carrier frequency there. Okay, we'll discuss the rest in class.